Hey guys, happy Friday. Okay, so today we are going to look at the lesson for 8.3, my mistake, for the volume of spheres. You watched the video yesterday, the video demonstration, and responded to that question, and after reading your responses, it looks like most of you really understood, but I'm just going to go over it one more time just to kind of solidify. So you looked at example or activity 2, deriving the F word, by the way, really funny with all the asterisks, loved that. Thanks for making me proud. For the volume of a sphere. Okay, so we saw in the video that the sphere was 2/3 of the volume of the cylinder. So we're going to multiply by 2/3 because the volume of a sphere is 2/3 of the volume of a cylinder. And we saw that when she, or he, I don't know actually, pushed the sphere into the full cylinder. Okay, so going down to the next step, we know that it's 2/3 times pi r squared times height. But if you're thinking about a sphere, you're not really thinking of it in terms of height, because if you have, I'm trying my best to draw I have no idea. 3-dimensional, yeah, that looks like a cylinder. But if you have a sphere and it's 3-dimensional, it's kind of awkward to measure the height. You would have to do it outside. So you can think of the height as, I've got a circle, 2 radii, actually. So we're going to say 2r for h. So here we'll put 2r instead of h. And then if we simplify, this is like, okay, we have 2/1, so 2 times 2 gives us our 4. 3 times 1 gives us our 3. And then this is the hard part right here. I'm going to change the color. We've got r squared and r. So many of us have not really gotten into exponents yet, but this is a really good skill that you can work on IXL if you choose to, because your logs are over. But anyways, if you're multiplying r squared by r, you get r to the 3rd power. Okay, so that's where the pi r cubed comes from. And I don't know if you thought about this, but kind of makes sense that it's cubed since we're dealing with a sphere, a 3-dimensional circle. So, yeah, kind of easy to remember. All right, so that is the preface for this lesson. We know that it's 4/3 pi r cubed. Okay, so jumping right into the first example. Finding the volume of the sphere, rounding to the nearest tenth. We are actually going to do that because our decimal place values are going to get kind of crazy. So we're going to do 4/3 pi times the radius, which is 4 cubed. And so 4 cubed is going to be 4 times 4 is 16. 16 times 4 is 64. So this is 64. And we still have 4/3 pi. So I always stop and think about what's the best way to evaluate this. Do I try to cross cancel here? I know that I can't, because if I add 6 and 4, that's 10. That's definitely not a multiple of 3. So I think the easiest way is just to multiply the 4 and the 64. So we have 256/3 pi. And then again, we're trying to find the best strategy. There's multiple ways you can do this, but we're just trying to find the way that is easiest. I thought about doing 22/7, but then when I tried putting 7 into 256, it didn't go unevenly, so I didn't think that that was the best method either. So I'm just simply going to do 3 into 256. And I get a repeating decimal of 3. So it's 85 3/10 repeating times pi. So my last step is just to do 314 by 85 3/10. And then go back and put your place values back in. That's 3. And you should get 267, and for rounding to the nearest tenth, you see why now we're doing that, because we're getting crazy decimals anyways. We'll say 8/10. And then the unit on this would be centimeters cubed. Now you will notice that your book has a different answer, and that's because they are using a calculator, which we know we are not doing. So remember that the pi button is actually more accurate than rounding it to 3 14/100ths, but because we refuse to use a calculator, our answer will be slightly off. It's worth it though. Okay, so the next example is a little different because they gave us the volume. So in this one, we are going to take the volume and plug it in. And we don't know what the R is, so we will leave it. So it's kind of weird. And you're thinking, what's the best strategy for this? Maybe you're thinking to cube root, but that's going to get ugly because you're going to have to cube root the 4/3 and the pi. So probably best bet is to get rid of this first. So we know that pi is technically in the numerator since there's nothing underneath it, so it's really 4 pi over 3 if you multiply across. 4 times pi is 4 pi, 3 times 1 is 3. So we're going to do the reciprocal. And that's going to cancel out all of this. So you'll be left with r cubed. And then on the other side, if we do 3 over 4 pi, we've got some work to do. Let's see, does 4, oh yeah, 4 does go into 228. Oops, 288. $72 times. So this would cancel out. Pi's are gone. The 4 is gone, and this is now 72. So all we have to do is 72 times 3, which is 216. And so since that's r cubed, we're going to take the cubed root to undo it. Inverse operations. And the cubed root of 216. So we're thinking what times itself times itself. So 4 times 4 times 4, we know it's 64. It's not going to be 5, but maybe we try 6. 36 times 6. And there it is. 6 inches would be our radius. Okay, you're going to pause to do these two on your own, and then come back and check your answers. Okay, I had to switch my pen writing because it was not enough space. Alright, so for the first one, as long as you didn't use a calculator, you should have gotten 2,143 and 4/10 feet squared. And then for the second one, 3 meters. Okay, last example. Was it this one that I wanted to talk about? Yeah, no, it was this one. Okay. Last example, we have a hemisphere, which is half of a sphere. Makes sense. Hemisphere, like northern hemisphere, right? Okay, so the top of the silo is a hemisphere with a radius of 12 feet. I'm going to go ahead in here and label that. What is the volume of the silo? So we're looking at two pieces here, really. We're looking at a cylinder on the bottom, and we are looking at a hemisphere on the top. Okay, so let's start with the easy one. The cylinder, the radius is 12, so we're going to do pi times our radius squared times our height. Now here's where we need to be careful. I don't know if you noticed this, but this line that's showing 52 feet is the height of the entire hemisphere, or the entire silo, I mean. So that includes the hemisphere. So really we need to take off that 12 right here, because this is another radius. So since this 52 includes this 12, it really should stop there. So let's take away 12 from 52, and we get 40. So the height of the cylinder only is 40 feet. The the height of the entire silo, including the hemisphere, would be 52 feet. So that's easy to make a mistake right there. Alright, so we have our radius squared times our height of 40. Alright, so that's going to give us 144 times 40 times pi. So 144 times 4, and I'll add a 0. And that is 5,760, and I'm going to leave it in terms of pi because we have another part to this. So now let's do the hemisphere. Okay, so we're going to do 4/3 pi times radius, times 12, which is our radius, cubed. And then we know that we're going to have to cut that in half, so you can either multiply by 1/2 or you can divide by 2 in the end. I think I am going to see what numbers I get first before I decide. So first of all, 12 cubed is going to be 144 times 12. And that's 1,728. And again, I'm still doing 4/3 and pi. So this is all multiplication here. Alright, let's see if this is divisible by 3. This 1,728 is 10, 17, 18. It is. So I can simplify that, see how many times it goes in. Again, that trick of divisibility rules. Key. Oops. That's not right. Alright, so 576 is what that reduces to. So now I have 576 here, and I have to still multiply by the numerator of 4. So 2,304, and I'm just going to divide that by 2 because remember we're doing half since it's a hemisphere. So 2 into 2,304. $1,152, and don't forget that that is pi. Okay, times pi. So we have our cylinder and we have our hemisphere. We're going to add those together. I'm just going to ignore the pi for a second. And that gives us 6,912 pi. So then we would just multiply it out. This is a real life problem, so honestly, you don't want to tell somebody, hey, you can fit 6,912 cubic feet of stuff. Times pi, though. I think they would think that we are crazy. They want the actual number. So we're going to take the time to multiply it out. Okay. Place value, just 2. So it should be about 21,703 and 68 feet cubed. Okay, and again, if you look at the book, it's different because they used the pi button all over the place. So this one is pretty significantly different. Well, maybe not. Maybe just in one place. When they did this with their calculator, those slackers, they got a much different answer than we did. But we are better in the long run for not using calculator. Okay, on your own, try these two, and again, be careful of the length here. Pause the video, come back and check. Alright, here we go. Here are the answers for the last two on your own. If you did not use a calculator, which you shouldn't have, and you rounded to the 10th place, you should get exactly the same thing that I am getting. Hopefully my math is all right. Yeah, that is it, guys. I hope you have a wonderful weekend. Bye!